So looking at this file, we have four separate number variables, each with a distinct type. And along with each one of those types, we have a matching function to go with it that essentially takes in that type and multiplies it by 2. So very simple code. However, this code is extremely redundant. The reason being is that each one of these functions, even though they take in a different number type, like a 32-bit int or a 64-bit int, it is doing the exact same thing. It is multiplying its parameter by 2. Is it really necessary for us to write four separate functions to essentially just multiply a number by 2? Because multiplying a 32-bit int by 2 is valid, and multiplying a 64-bit int by 2 is valid. And the answer to that question is yes, you do have to. The reason why is because we're dealing with a statically typed language. So if I have a function that expects a 32-bit int, you can't just pass a 64-bit int and expect it not to complain. And just to test that out, if I pass in num2 into this first function, I'll try casting already, but we'll see that we get an error. Cannot use variable of type int64 as int32 value in argument. So we essentially are forced to make sure that the type that we actually pass into the function matches what's in its parameter list. However, like mentioned, this is very redundant. So generics essentially allow us to unify types, or more so declare types as parameters. So instead of having all of these four functions, each essentially doing the same thing, simple, but they're just taking in a separate number type, let's write one unified multiply function. So I'll call it multiply. And before I actually write out its parameter list, I'm going to define its generic types, essentially its type list. And I can do so by adding some brackets. And the alias I'll give for the type is going to be T. That's the common convention in Go. And here I can write out all the different types I want this function to support. So I can write a 64-bit integer, a 32-bit, and I'll do the exact same thing for floats. And now that I have this new T type that essentially supports all of these separate types, I'll just write our number parameter and I'll give it a type of T instead of a built-in number type. And since we're multiplying T times 2, we're going to return T. So now I have a unified function that essentially takes in each one of these, any one of these types, and multiplies it by 2. So let's actually try replacing all of these function calls with our new function. And as you guys see, we get absolutely no errors, and we have a lot less code. We're able to deal with a various amount of different number types and have a singular function that works with all of them. So if I run this code, let's see what we get. And we get a valid result in the terminal.